This conference
So
will now
today
be recorded.
we'll start with the next assignment explanation, assignment number 6 in case of mandatory assignments. Here we have to implement the LED dimmer application. So already you know how to control the brightness of an LED. But here we are going to use timer based ISR only, which means whatever the LED on and off logic is there, we are going to write that inside the ISR. The same logic we have implemented, right? On which assignment we have implemented this? The same logic, like same LED dimmer application only, same timer based ISR. Yes, very good. Assignment number 5. So here the same, we are going to control the brightness of an LED by using the same timer based pulse width modulation. So now what is the difference between assignment number 5 and assignment number 6? Like the output is same, but how we are going to control the brightness, that is the difference here. So in case of assignment number 5, we have used two digital keypad switches. One is to increase the brightness, another one is to decrease the brightness, right? This is what we did in assignment number 5. The same thing here for the assignment number 6, but here instead of the switches, yes, we have to use a potentiometer. We'll be having two potentiometer. On our board, we'll be having two potentiometer. So the very first potentiometer we are going to use here. Okay, we have to use the potentiometer. So now, whenever I power up the board, whenever I power up or reset, whatever the potentiometer value is there, based on that value, I'm going to control the brightness of the LED. Okay, I'm going to control the brightness of an LED by using the potentiometer value. So first we'll see the execution, later we'll come to the implementation part. So you can observe here, as soon as I power up or reset, based on the potentiometer knob, we have to control the brightness. So we'll be using potentiometer, first potentiometer, okay, potentiometer 1. And we are going to use only one LED. Here I am using port D, D0th LED. I am using port D, D0th LED. So here observe, as soon as I power up or press reset, what is happening here? Initially my potentiometer it is off in the half of the position, right? Potentiometer is half of the position. Since it is half of the position, you can see here port D D0 LED, it is showing the 50% of the brightness. It is showing the half of the brightness. If I move towards this clockwise direction, can you observe the changes to the D0th LED? Can you tell me what is happening to the D0th LED? What happened here? Whenever I rotate the knob towards a clockwise direction, what is happening? Yes, the brightness has been increasing. So clockwise direction, the brightness has to increase. Now I am going to rotate it towards the anti-clockwise direction. Now can you tell me what is happening to that LED? What is happening here? It is decreasing the brightness. So we have to control the brightness of an LED by rotating the potentiometer knob. Okay. Coming to the implementation part. Second same, here we'll be having a void main function. Void main function. Okay. So now first we'll complete this main function. So here first we have to call the init config. We have to call the init config function. So in case of init config, can you tell me what are all the peripherals I have to configure? We are using LED, so we have to configure LED. Then we are using potentiometer, so we have to configure the ADC. And here we are using a timer based ISR, we have to configure timer. So LED, ADC and timer we have to configure. Now we'll be having our logic part inside the while one. Inside the while one, we'll be having our logic part. So now we'll come to this logic part. First we'll complete the ISR, because ISR is the one, inside this one only we are going to implement our LED on and off logic. We'll be implementing our LED on and off logic. Only for that purpose we'll be using the ISR. Okay. This ISR is used to generate the pulse between the LED. So now coming to the while one. So here based on the ADC value only, we are going to take our duty cycle. So for that, which function we have to call? We'll be having a function called read ADC function. To this read ADC function, what we have to do? We have to pass our channel number. We have to pass our channel number. Okay. Where I can find this information, channel number information? Where I have to refer about this channel number information? Where I can see, like, I want to know to which channel our potentiometer one is connected. Data sheet. Very good. Schematics. So inside the schematics only, it will be shown like this particular potentiometer is connected to the this particular channel number. So refer the schematics, and here you are going to mention our channel number. Now, if I call this function read ADC, can you tell me what this function will return? What read is ADC function will return? Based on the potentiometer position, it will return the ADC value. It will return one ADC value. Based on the potentiometer position, it is going to return the ADC value, right? So now, can you tell me what is the range of our potentiometer? What is the range of our potentiometer? In the sense, what is the resolution I'm asking? What is the resolution of ADC? Resolution of ADC, whether it is a 8-bit ADC or 10-bit ADC or 16-bit ADC. What is the resolution? No, it is not 8-bit. It is 10-bit resolution. Our potentiometer or our ADC, it is of a 10-bit resolution. Since it is a 10-bit, what is the minimum value we can store? 0. What is the maximum value we can store? 1023. Minimum value is 0, maximum value is 1023. So now this is the value we'll be getting from the read ADC function. Yes or no? From the read ADC, we'll be getting a value ranges from 0 to 1023. But for what purpose we are using this ADC value? For the duty cycle. Yes or no? We are reading the potentiometer value in order to assign this to the duty cycle. But our duty cycle, it ranges from 0 to 100. Duty cycle ranges from 0 to 100. Yes or no? Now, whatever the value I'm getting from the read ADC, I cannot directly assign to this duty cycle. Agree? Whatever the value I'm reading from the read ADC, I cannot simply assign this to duty cycle. So first what we have to do, whatever the value we are having, we have to convert it to between the range of 0 to 100. Okay, whatever the value I'm getting from the ADC, that I have to convert first between the range of 0 to 100. So then whatever the conversion value is there, I'm going to assign it towards a duty cycle variable. So for that, whatever the value ADC function is returning, that I'm storing into a variable called ADC val. So now whatever the value I'm having, I have to convert it between the range of 100. So what I have to do in order to get to the exact value, divide it by 10.23. Yes or no? Whatever the ADC value we are getting, just divide it by 10.23. So now we'll be getting a values between the range of 0 to 100. Now we can assign that value to the duty cycle. Now we can assign that value to the duty cycle. Only this much you are going to do. Call the read ADC. Whatever the ADC value I am getting, I have to convert that value into the range of 0 to 100. After that, we are going to assign. That's it. So whatever the LED on and off logic you have implemented, the same logic you are going to use here. So based on the potentiometer position, it will fetch the value, then convert that value, then assign that value to the duty cycle variable. Clear? If you have any doubts, please post it on the chat box. Shall we move to the next assignment? Since nobody posted any questions, shall we move to the next assignment? Okay. Okay. So next, we'll move to the next assignment, assignment number 9. So here we are going to implement a temperature sensor node with the CLCD display. So here we are going to use two peripheral, one is temperature sensor, another one is CLCD. So what we are going to do here? So as soon as the board is powered up or reset, so on the CLCD display line 1, we have to display some title. Okay. On the CLCD line 1, we are going to display the title. On the second line, we have to display the room temperature, which means I am going to use a temperature sensor. Based on the sensor value, I am going to display the temperature over the CLCD. Clear? So now, can you tell me on our board which peripheral is available for us in order to fetch the temperature? On our board, can you tell me which peripheral is available for us to sense the temperature? Very good. LM35. So below the heater or cooler, we'll be having a temperature sensor as LM35 sensor. Here we are having that. Now based on the sensor value, I am going to display the temperature on the CLCD. First, let me show you the output. Let me load the hex file. So now we can see, as soon as I power up or reset my board, on the CLCD line 1, I am displaying the title messages temperature. On the CLCD line number 2, I am displaying the temperature, which is in degree Celsius format. Degree Celsius format. We have to read the temperature from the sensor, and then whatever the value it is returning, based on that we are going to display the temperature over the CLCD. Clear? So in this particular assignment, what we are trying to do is, so first here we are using some two peripherals. We have to configure that peripheral. So I'm going to call init config function. Can you tell me what are all the things I have to configure here? Yes, obviously we are using CLCD. We have to configure CLCD. And then one more peripheral I am using, temperature sensor. So for that, which one we have to use? We have to use the ADC. Very good. We have to use analog to digital converter, because it is a sensor. Whatever the sensor value is there, we have to convert it towards a digital value, right? So these two things we have to configure. Then we can move to our logic in case of while one. So here, whenever I power up or reset the board, first what I have to do, on the CLCD line 1, I have to display the title. I have to display the title. So what is the title I am displaying? Temperature. I am displaying the title as temperature. Yes, on line 1, we have to display this. I'm not calling any function, just I'm writing it, that's it. So we have to display the temperature. Next, on CLCD line 2, what we have to do? We have to display that actual temperature, like 27 degree Celsius we have to display. So you can see here, along with the characters, here you can see on the CLCD, we have to display the degree symbol. We have to display the degree symbol, right? So how to display that? How to display that? In order to display the degree symbol, okay, what you have to do, you have to refer the data sheet of CLCD. So we'll be having a separate data sheet for the CLCD towards this data sheet, you have to remember what is the hexadecimal value I have to send to the CLCD in order to print the degree symbol. This you have to find it out. Go open your CLCD data sheet. There will be having many symbols to be printed. In order to print that respective symbol, you have to fetch the exact value from the data sheet. Based on that, you are going to display. Okay. This C is a character we can normally display C. Now, coming to this value. So, I have to display some value towards the CLC, right? Now, I have a question. Now, I have a question. Like, first what I have to do in order to display the degree or temperature, first what I have to do, first I have to read the temperature value. For that, what I have to do, I'll be calling read ADC function. To this function, pass the channel number to which channel this particular temperature sensor is connected. Pass the channel number. So it will return the value from the temperature sensor, right? First read a value from the temperature sensor. So now whatever the temperature sensor value is there, is it an exact degree Celsius format? Whatever the read ADC function is returning, is it an exact temperature degree Celsius value? No, it is just a sensor value. It is not exactly degree Celsius. It is a sensor value, ADC value, some temperature sensor. Now what I have to do, I have to convert the ADC value to degree Celsius. I have to convert the fetched ADC value to the degree Celsius. In order to convert this, we are having few steps. First, we'll go with the step number 1. We'll go with the first step number 1. First, we have to find the voltage. How to find the voltage? We are having a formula in order to calculate the voltage. Voltage equal to ADC value, whatever the value is returning from the function, multiplied by the step size. This is the formula to calculate the voltage. And now this ADC value will be fetching from the read ADC function. But what is the formula to calculate the step size? What is the formula to calculate the step size? Have you remember? V max minus V minimum divided by 2 to the power resolution. This is the formula. So here, whatever the ADC value it is returning, first we have to convert that value towards a voltage. We have to fetch the voltage. From the voltage only, we are going to convert into a degree Celsius format. So whatever the ADC value it is returning, that I'm going to multiply it with the step size. So we have a formula for the step size. Maximum voltage minus minimum voltage divided by 2 to the power resolution. So we'll be choosing the maximum voltage as 5 volt and we'll be choosing the minimum voltage as 0 volt. And can you tell me what is the resolution of our ADC? It is of 10-bit resolution. Substitute the value, calculate the step size, and whatever the step size you have calculated, just multiply it with the ADC value. So that we'll be getting the voltage. So our first step is ready. Whatever the ADC value I am reading from this function, I am going to convert that into a voltage. Clear with the step number 1? Clear with step number 1? Okay. Now, we'll move to the second step. Still, I got the voltage, but here I'm not going to display that voltage. Instead, I'm displaying it into a degree Celsius. So, step number 2, we have to convert voltage to Celsius. We have to convert the voltage to Celsius. Now we have to convert this. So can you tell me how many milliwatt equal to 1 degree Celsius? So 1 degree Celsius equal to 10 millivolt. 1 degree Celsius is equal to 10 millivolt. Now, whatever the thing we have calculated, it is a volt. It is not millivolt. Whatever we have calculated, it is a volt. It is not a millivolt. So what we have to do, again we have to convert, yes, again we have to convert the voltage to millivoltage. We have to convert the voltage to a millivoltage. Yes, 1 voltage equal to 1000 millivolt. 1 voltage equal to 1000 millivolt. So whatever the voltage we have calculated here, that we have to convert it into a millivolt. So 1 millivolt is equal to, 1 volt equal to 1000 millivolt. Okay. Assume, for example, we'll take some calculations. Now, for example, I want to convert 2.5 voltage of current to the millivolt. I want to convert 2.5 voltage of current towards a degree Celsius to degree Celsius. For that, first what I have to do, I have to convert this into a millivolt first. Yes or no? I want to, my voltage is 2.5. I want to find the equivalent value of Celsius. In order to find the Celsius, first I have to convert this 2.5 voltage of current to millivolt. I have to convert. 1 millivolt equal to, 1 voltage equal to 1000 millivolt. So how can I convert this? Yes, multiplied by 1000. 2.5 voltage multiplied by 1000. So we'll be getting the millivolt as 2500 millivolt. 2500 millivolt. Now, whatever the voltage I'm having, by using this, I have converted that into a millivolt. After that, what I have to do? I have to convert the millivolt to the degree Celsius. After that, I have to convert this millivolt to the degree Celsius. So now, here 1 degree Celsius is 10 millivolt. But here I am having 2500 millivolt. So how can I convert this? How can I convert this? So Celsius is equal to 2500 millivolt divided by 10 millivolt. 2500, whatever the millivolt we are having, divide that by 10 millivolt. So now what will be the Celsius value? 250 degree Celsius will be having. So now if I got the voltage is 2.5, the equivalent degree in Celsius is 250 degree Celsius. So we have to use these two steps in order to convert our ADC value into a Celsius value. Clear? First we have to find the voltage and then we have to convert that voltage into the Celsius. For that we should take a millivolt, right? So 1000 millivolt equal to 1 voltage. So we have to convert that. So based on the conversion, we'll be getting the final resultant degree Celsius. Clear? So after reading this value, step number 2 is what? We have to convert the ADC value to the temperature or the Celsius value to Celsius. In order to do this conversion only, again we'll be having two different steps. Now I have converted this. Now I have the degree Celsius value, but it will be some integer value, right? But what I have to do, I have to display this. I have to display the Celsius to CLCD. If I want to display in the sense, in case of CLCD, we have to display the character. We have to display the character. Now what I have to do? I have to convert the value to character. After converting, we can print it on the CLCD. So after that, we have to print the temperature on CLCD line number 2. Clear? Whatever the fetched value is there, just convert into a degree Celsius by using this method. After that, we have to display the Celsius to the CLCD. It will be an integer value. We have to convert that into a character. After that, display that character. So only this much is the assignment. So now here you can observe one thing. It is continuously showing same value, right? So here we are using a simulator. So it will be displaying the same constant value. If you are dumping or if you are loading the same hex file to a hardware board, like real-time word in the board in the sense, the value it will change. So here it will not change since it is a simulator. No, it is a general mathematics, Mahesh. It is not in the data sheet. It is a general mathematics. This much is your assignment. So today two assignment is enough. So whatever the doubts you are having, please post it on the chat box. Please post your doubts on the chat box. If you have any doubts, please post it on the chat box. LM35 is a sensor, right? How we are reading the value from the sensor based on this read ADC function. So we know that the range of the read ADC, it is always from 0 to 1023. Yes or no? So our register, it is a 10-bit resolution. So from the controller, sorry, from the sensor, we'll be reading the value and we'll be converting that value towards a analog to a digital value. Whatever the sensor is giving, it is of analog value. By using this read ADC and all, it will read from the particular sensor and we are converting that. Our final converted value, it will be in the range of 0 to 1023. Since it is a simulator, it is showing 27.0. But if you are using the hardware board, like any controller hardware board in the sense, if you change the room temperature and all, it will display some other temperature. Based on your room temperature, it will display. From the LM35, we will not get any voltage. We'll be getting the 10-bit value will be there. We have to convert that value into a voltage. Like while choosing your ADC, like init ADC function, there only will be having a bit, like in order to choose the maximum voltage and minimum voltage. Our maximum voltage will be selecting it as 5 volt and the minimum voltage will be selecting it as 0 voltage. So whatever the voltage we are converting, it will be in the range of 0 to 5 voltage. Then Mahesh, then you have to first understand about this ADC, what this read ADC function is doing. So read ADC is a function like here we have to pass our channel number. From the channel number, it will read one analog value. Whatever the analog value it read, that value will be converted into a digital value, and the final whatever the value is written from the ADC function is nothing but 0 to 1023 is the range. If you have any doubts, please post it on the chat box. Meanwhile, you can mark your attendance. If you have marked your attendance and if you don't have any doubts, you can leave the session. Whoever is having the doubts, you can post it on the chat box.